Those who aren't fond of salty flavors may consider pickled cucumbers as their enemy. But for the rest of the world, pickled cucumbers are not just a crunchy delight in every meal. They are a golden spice driving the global food industry forward. So, have you ever wondered how millions of tons of pickled cucumbers are produced each year? The journey of this humble plant begins in vast fields, where cucumbers are carefully cultivated and harvested at their peak ripeness. From there, these fresh, crunchy cucumbers are transported to modern factories, where, under the hands of skilled workers and advanced machinery, they are not only transformed into a tangy and crunchy treat loved by billions of food enthusiasts worldwide, but every remaining part is also used in an environmentally sustainable agricultural production process. Today, Agriculture Insight will take you inside some of the world's most advanced pickle factories and uncover the many fascinating secrets behind this incredibly versatile food. All of that and more right here in this video. Imagine standing in the middle of vast, lush cucumber fields, bathed in sunlight, stretching endlessly to the horizon. Welcome to China, the king of agriculture, where over 77 million tons of cucumbers are harvested every year, accounting for up to 80% of global production. However, production alone is not everything. When it comes to pickles, the United States is the true king, with renowned brands like Vlasic, Mount Olive, Clausen, and a pickled cucumber industry worth billions of dollars, closely tied to the fast food boom. With their sharp, salty flavor and irresistible crunch, stand out as a refreshing contrast to other pickled products like brined olives or pickled beets, offering a distinctive tanginess along with the added benefits of probiotics that help support digestion and improve gut health. Among over 100 varieties of cucumbers, only a few have thin skin, few seeds, are crunchy, and absorb flavor well, making them suitable for pickling. However, even within that group, only the high-quality 5 to 8 centimeters gherkin cucumbers, out of millions, are selected to create the tangy, crunchy pickles that are the soul of millions of jars worldwide. This explains why gherkin pickles, with a history spanning over 4,000 years, continue to exist and have become the golden spice, beloved globally and playing an essential role in the food industry. And every legend has a starting point somewhere. For pickles, the iconic sidekick that has won over millions of food lovers around the world, that journey begins in the sun-drenched, green cucumber fields. From May to July each year, the cucumber fields become more vibrant than ever as the harvest season officially begins. On the vast fields stretching endlessly, modern machines, large, precise, and powerful, have become the extended arms of farmers during the busy season. As the machine moves along each row of cucumbers, the harvesting head functions like a giant comb, brushing through each stem and guiding the vines into the machine. Inside, an automatic sorting system removes unnecessary leaves and stems while only keeping the cucumbers that meet the standards and transferring them to the conveyor belt behind. Unlike the modern potato harvesting machines from Grimm or John Deere, which are designed to dig up soil and separate potatoes from the ground with a capacity of up to 20 tons per hour, cucumber harvesting machines are built to be lighter and more precise, allowing them to harvest cucumbers without crushing the fruit, with a capacity of around 5 to 10 tons per hour. Traditional farming still yields stable cucumber harvests, but relies heavily on chemicals. In this context, organic farming, hydroponics, and greenhouses are gradually becoming the trend due to their ability to optimize yield, minimize negative environmental impacts, and address consumer concerns about pesticide residues and herbicides. Although technology has advanced significantly, it is the diligent hands of workers that still bring superior quality that machines cannot replace. Workers carefully pick each cucumber by hand, selecting those that are ripe and of the right size, then place them onto a moving conveyor belt attached to the harvesting machine or specialized trailer, helping transport the cucumbers to the storage containers quickly and gently. Manual harvesting, although much less efficient compared to modern machines with a capacity up to 15 times higher, ensures the finesse and precision that machines cannot achieve. After harvesting, trucks quickly transport the cucumbers to processing factories within 2 to 4 hours, preserving their freshness, crispness, and texture before embarking on the next secret journey, becoming the tangy, crunchy pickles that captivate the world. At the pickle processing plant, trucks carrying millions of tons of fresh cucumbers line up one after another, entering the raw material intake area. In modern factories, cucumbers are introduced into a closed-loop washing system, with multiple stages designed to ensure food safety and high input quality. First, cucumbers from transport trucks are poured into large indoor water tanks. These tanks contain clean, continuously recirculating water, often treated with ozone, diluted chlorine, or light brine to eliminate surface contaminants. The gentle water flow helps rinse off soil and debris while moving the cucumbers toward the conveyor belt without causing any bruising. Next, the cucumbers pass through a high-pressure multi-directional spray tunnel, typically 4 to 6 bar, where powerful water jets thoroughly remove dirt and bacteria. The water used in this stage is filtered and reused through a closed system involving mesh filters, activated carbon, and UV or ozone sterilization, ensuring both hygiene and resource efficiency. This process doesn't fully eliminate pesticide or chemical residues, which may remain on the fruit's surface. Therefore, to ensure consumer health and safety, factories must conduct strict checks in addition to following farming standards. Modern methods like HPLC and MS detect pesticide residues with high accuracy, with residue levels ranging from 0.05 milligram to 5 milligrams per kilogram, depending on the pesticide and regulations. Now here's where it gets interesting. There are 2 popular methods, each with its own secret formula for making pickles: natural fermentation for traditional and premium lines, and quick vinegar pickling for industrial products. First, for the natural fermentation method, cucumbers are sorted and then placed into large fermentation tanks, often positioned outdoors to take advantage of the ambient temperature, providing ideal conditions for fermentation. This method not only saves energy, but also promotes the growth of beneficial bacteria, which in turn creates the characteristic sour taste and increases the probiotic content in the final product. Each tank is filled with brine solution, a mixture of salt water and spices like dill, garlic, pepper, bay leaves, and others, depending on the unique recipe of each brand. The cucumbers are soaked in brine for 1 to 4 weeks, depending on the thickness of the skin, the type of product, and the desired flavor. It is the clever use of ambient temperature to promote the development of beneficial bacteria during fermentation, combined with the long soaking time, that is the key to creating the difference in flavor and crunchiness between the natural fermentation method and the quick vinegar pickling method. Once the fermentation period is complete, the pickles are carefully removed from the brine tanks and immediately transferred to the processing line for final cleaning and inspection. At this stage, each pickle is thoroughly rinsed to remove any excess brine, spices, or sediment that may have settled during fermentation. After rinsing, the pickles pass through a visual inspection system, either by trained workers or automated optical scanners, to detect and remove any defective or damaged pieces. Next, the pickles are sorted by size and shape using precision mechanical graders, ensuring uniformity in the final product. They are then transferred into filling machines, where they are packed into jars or food-grade barrels. Before sealing, each container is filled with a final brine solution, either the original fermented brine or a fresh one prepared under sterile conditions, to maintain flavor and preservation. Finally, the sealed jars undergo pasteurization in hot water baths or steam chambers, depending on the product type and shelf life requirements. This step helps to stabilize the pickles, ensuring food safety while retaining their natural crunch and probiotic benefits as much as possible. In contrast, the vinegar pickling method takes only a few hours, meeting the enormous demand with billions of jars produced worldwide each year, and a longer shelf life, all while being about 4 times cheaper than naturally fermented products for the same volume. And this is why this method is so effective. After being thoroughly washed and sorted, the cucumbers are placed directly into pre-sterilized glass jars or plastic containers to ensure absolute hygiene. Before the cucumbers are added, dry spices such as dill, garlic, mustard seeds, black pepper, and bay leaves are added to infuse natural fragrance. The cucumbers are then automatically divided into the glass jars. In addition to whole pickles, many products are also sliced into rounds, cut into chunks, or shaped in various ways, perfect for topping McDonald's or Burger King's burgers, or served with salads and sandwiches at chains like Subway and KFC. After the cucumbers are divided into jars, they are moved to the brine filling area, where the soaking solution is added to complete the flavor and preservation structure of the product. The key difference in this step lies in one essential ingredient: vinegar. For industrial pickle products, due to the lack of natural fermentation time, the brine solution must include vinegar, acetic acid, at a ratio of 5 to 10% combined with salt, sugar, and other spices. While the natural fermentation method requires refrigeration to maintain freshness and is typically consumed within a few months, vinegar provides an immediate sour taste. It also acts as a natural preservative, allowing the product to be stored at room temperature for up to a year or longer, making it more convenient for large-scale distribution in the global industry. For industrial pickle lines, this is also the beginning of the short fermentation process, which is strictly controlled for temperature and humidity, ensuring the product achieves a consistent flavor and standard crunchiness. So is naturally fermented pickled cucumber or quick vinegar pickled cucumber your idea of the perfect jar of pickles? The next step is pasteurization. Typically, the jars of pickles are placed in a continuous pasteurizer or high-pressure retort, where they are heated to a temperature between 80 degrees Celsius and 100 degrees Celsius for 10 to 30 minutes. After leaving the heat chamber, the product is rapidly cooled by passing through a cold water spray system, combined with high-powered fans placed along the conveyor belt, which helps quickly lower the temperature and prevent overheating or changes in the pickle's texture. Most naturally fermented pickles don't require pasteurization, as the fermentation process creates an acidic environment that inhibits harmful bacteria and preserves beneficial probiotics. Finally, the jars of pickles are placed on a conveyor belt and pass through an automatic labeling system. Each label clearly displays the product name, ingredients, production date, and expiration date. This step ensures that all jars have consistent, accurate, and compliant information for distribution. Pickles not only play a vital role in the global economy, generating billions of dollars in revenue each year, but also serve as a cultural bridge, connecting diverse culinary traditions and bringing the distinctive sour flavor of 4,000 years of history to kitchens around the world. Radishes come in various shapes, sizes, and colors, making them one of the most visually diverse vegetables out there. The most common radishes in the United States are small, round, and red with a crisp white interior. Radishes originated from Southeast Asia and spread to other parts of the world due to their adaptability and quick-growing nature. These hardy vegetables thrive in cool climates and prefer well-drained, sandy soil. The growing season for radishes is short, with some varieties maturing in as little as 3 weeks. Harvest time is critical for radishes. Picking them too early can result in underdeveloped roots, while waiting too long can make them lose their characteristic crunch and flavor. The perfect radish is firm, juicy, and peppery, making timing everything in the radish growing game. Harvesting 110 million pounds of radishes is no small feat. American farmers use a mix of industrial machinery and traditional hand-picking methods to ensure these root vegetables make it from the fields to our tables in pristine condition. Modern radish farming relies heavily on specialized harvesting machines. Unlike the massive equipment used for crops like wheat or corn, radish harvesters are compact and designed for gentleness. These machines are equipped with sharp, precise cutting tools that slice the radishes cleanly at the root level without damaging their delicate skins. The harvested radishes are then gently lifted onto conveyor belts and sorted. One of the standout features of these machines is their ability to handle radishes with care. Despite the high efficiency of these machines, which can harvest acres of radishes in hours, they operate with a light touch to avoid bruising or breaking the radishes. Their design prioritizes speed and quality, ensuring that the radishes retain their market-ready appearance. Machines often incorporate advanced technologies like sensors to distinguish between ripe and unripe radishes, ensuring only those at peak readiness are harvested. This level of precision minimizes waste and maximizes yield, which is critical when dealing with such a large-scale operation. In greenhouses, where the environment is carefully controlled and crops are nurtured to perfection, harvesting radishes requires a level of finesse that larger agricultural equipment simply cannot provide. This is where small-scale harvesting machines come into play. Designed specifically for delicate operations, these compact machines are tailored to meet the unique demands of greenhouse farming, where precision and gentleness are paramount. These machines are equipped with specialized cutting mechanisms that cleanly sever radishes from their stems without causing damage to the delicate roots or surrounding plants. Unlike their larger counterparts, which prioritize speed and volume, these small harvesters focus on ensuring that each radish is handled with care. They often include soft conveyor belts and padded collection trays to minimize bruising, preserving the radish's pristine appearance and crisp texture. Additionally, the compact size of these machines allows them to navigate narrow greenhouse rows with ease, ensuring maximum efficiency in tight spaces. Some models even feature adjustable settings to accommodate radishes of various sizes and growth stages, further enhancing their versatility. In smaller farms or for specialty radish varieties, hand harvesting is still widely practiced. Workers move row by row, carefully pulling radishes from the soil, shaking off excess dirt, and inspecting them for quality. While this method is labor-intensive and slower, it allows for meticulous quality control, especially for radishes destined for premium markets. Hand harvesting also ensures that radishes with unique shapes or delicate skins are treated with extra care. Workers' experience and skill play a crucial role in delivering perfectly fresh and unblemished radishes. Additionally, hand harvesting allows farmers to select radishes for specific purposes, such as bunching for farmers' markets or setting aside those best suited for pickling or slicing. This method, though traditional, is indispensable for preserving the diversity and marketability of radishes. Whether harvested by hand or with the aid of machines, the process of gathering radishes demands precision, care, and keen observation. Radishes are delicate vegetables with crisp skins and tender roots, and any mishandling can result in bruising or damage that affects their quality. Harvesting machines, while efficient, are designed with features like gentle conveyor belts and precise cutting tools to ensure the radishes are carefully detached from their stems without harm. Similarly, hand harvesting requires an experienced touch. Regardless of the method, the goal remains the same: to deliver radishes that are vibrant, unblemished, and ready to add crunch and flavor to any meal. Once harvested, radishes embark on the next stage of their journey: processing. This step is crucial for ensuring that the radishes are clean, safe, and ready for consumers. The journey of radishes from farm to table begins with a thorough cleaning process at the factory. When radishes arrive, they are often coated in soil and debris from the fields. To prepare them for market, they are passed through a series of advanced washing stations. High-pressure water jets work in tandem with soft, gentle brushes to remove dirt while preserving the integrity of the radish's delicate skins. This meticulous cleaning process not only enhances the radish's visual appeal, but also ensures that any potential contaminants, such as pesticides or bacteria from the field, are effectively eliminated. In some facilities, the cleaning process goes a step further with the use of ozonated water or mild organic sanitizers. These additional measures provide an extra layer of hygiene, killing bacteria and extending the radish's shelf life without compromising their crisp texture or natural flavor. This step ensures that consumers receive radishes that are both safe and fresh. After washing, radishes are sorted by size, color, and quality. Larger radishes are often sold whole, while smaller or slightly misshapen ones might be sliced or processed for other uses like salad mixes or pickles. Sorting not only ensures consistent quality, but also allows producers to meet diverse market demands. For instance, perfectly uniform radishes may be packaged for retail, while irregular ones might be destined for food service or value-added products like radish chips or powders. Once cleaned and sorted, the radishes move to the packaging stage, where they are carefully packed to suit different markets. Some are placed in breathable plastic bags designed to maintain freshness, while others are packaged in bulk for industrial use or restaurant supply. Labels are meticulously applied to showcase important details like variety, origin, and certifications, including organic or non-GMO status. To meet growing consumer demand for sustainable practices, many producers are adopting eco-friendly packaging solutions, such as compostable bags or minimalistic wrapping. These innovations not only align with environmental values, but also ensure that radishes reach consumers in a way that reflects modern sustainability goals. Planting radishes is a straightforward yet rewarding process, making them a favorite among farmers and home gardeners alike. The process begins by preparing the soil, loosening it to allow roots to develop fully and removing rocks or debris. Seeds are sown directly into the ground, typically about half an inch deep and spaced an inch apart. Radishes grow best in rows, with sufficient space between them to prevent overcrowding and promote air circulation. One of the most remarkable aspects of radishes is their rapid growth. Some varieties, like Cherry Belle, can mature in as little as 20 days. Farmers often plant radishes successively every few weeks to ensure a continuous harvest. Regular watering is essential, as radishes need consistent moisture to develop their signature crisp texture. Radishes may seem humble, but their cultivation supports a vast network of farmers, factory workers, and logistics professionals. The economic footprint of radish farming is significant, contributing millions of dollars annually to the agricultural sector. Beyond economics, radishes have cultural value as well. They feature prominently in cuisines worldwide, from Korean kimchi to French breakfast radishes served with butter. In the US, radishes are increasingly popular in health-conscious diets, adding a peppery crunch to salads, tacos, and grain bowls. The versatility of radishes also sparks innovation in the food industry. Companies experiment with radish-based snacks, pickled products, and even beverages, broadening their appeal and market reach. Harvesting 110 million pounds of radishes annually is a testament to America's efficient and innovative agricultural practices. Radishes may be small, but their journey from seed to table is a big deal. The dedication of farmers, workers, and processors ensures that this often overlooked vegetable remains a staple in American kitchens. So next time you bite into a crunchy radish, take a moment to appreciate the care and effort behind its journey. It's not just a vegetable, it's a story of agricultural passion and precision. Exploring the vast fields of California, it's easy to see why this state is called the carrot capital. California's warm, sunny climate, sandy, well-drained soil, and advanced irrigation systems create the perfect environment for carrots to thrive. Thanks to these ideal conditions, carrots have become not only an essential crop, but also a major economic contributor, with an estimated value of $1.823 billion in 2023. The success of the carrot industry begins with soil preparation and seed planting, where advanced technology plays a crucial role. Before planting, the soil is carefully treated using modern machinery to ensure it is loose and well-drained, two key factors for healthy plant growth. Next, the soil is leveled and shaped into raised beds with appropriate spacing to ensure proper drainage and ease of crop. Once the soil has been prepared, an automatic seeder is introduced. Healthy carrot seeds that have been treated with chemicals are poured into the seeder's container. Smart seeders equipped with GPS and precise sensors ensure seeds are evenly distributed with perfect spacing between rows. The spacing between carrot seeds sown using a seed planter is typically 0.8 to 2 inches. This spacing ensures that the plants have enough room to grow without overcrowding, allowing the carrots to develop straight and uniformly. Throughout the growing process, American farmers take meticulous care of carrots. Automated irrigation systems and sensors that monitor soil temperature and moisture ensure the ideal environment for the crops to thrive. Farmers also use organic fertilizers and advanced pest management techniques to protect the carrots while keeping the process environmentally friendly. Every stage of growth is closely monitored to ensure the plants grow uniformly and meet high-quality standards, satisfying the large demand both domestically and internationally. When the lush green fields of carrots begin to fade to a pale shade, it's a clear sign that harvest season has arrived. After 70 to 80 days of growth, the carrots reach their peak condition, with smooth, firm skins and a vibrant orange color. To ensure an efficient harvest and maintain the highest quality, farmers use advanced machinery that makes the process quick, precise, and labor-saving. The harvester they use is designed to handle the entire process, from lifting carrots out of the ground to basic cleaning and separating the leaves from the roots. The cutting blades at the base of the machine slice through the stems and gently lift the carrots out of the soil without causing any damage. Simultaneously, an integrated conveyor system moves the carrots upward, where dirt and debris are partially removed using fans and a vibration mechanism. Once the carrots are cleaned, the leaves are cut off and left on the field, reducing transport weight and returning organic matter to the soil. The cleaned carrots are then transferred directly into large bins on trucks moving alongside the harvester. This machine significantly improves efficiency, saving both time and labor compared to traditional manual harvesting methods. In some areas, a combined harvesting system with 2 machines is used. These machines work closely together to complete the process efficiently. The first machine removes all the carrot tops using a specialized cutting system that only removes the leaves without affecting the carrots underneath. The leaves are left on the field to improve soil fertility. The second machine uses deep cutting blades to gently lift the carrots from the soil without causing any damage. The cleaned carrots are then transferred onto a conveyor belt and moved directly into large bins on nearby trucks, while the soil is left behind in the field. This process ensures high-quality carrots, reduces costs, and increases overall harvesting efficiency. The use of advanced machinery in carrot harvesting has truly revolutionized American agriculture, prioritizing efficiency, quality, and sustainability. Modern harvesting machines with integrated features have made the process faster, more precise, and cost-effective than ever before. Additionally, high-tech machinery optimizes labor resources by freeing workers from physically demanding and time-consuming tasks. This not only lowers labor costs but also reduces pressure on workers, allowing them to focus on other important aspects like quality control or preparing for future crops. More importantly, the use of modern machinery brings consistency to the production process. Carrots harvested with advanced machines not only meet strict standards for shape and size, but also retain their freshness thanks to the quick and precise handling. This is especially critical in today's market, where quality demands are high, particularly in export markets that adhere to rigorous international standards. These machines ensure that every carrot from field to table meets consumer expectations with consistent quality. Beyond improving efficiency, high-tech machinery in carrot harvesting carries significant benefits for sustainable agriculture in the U.S. Automated systems reduce resource waste, limit emissions from transportation, and enhance soil regeneration. This demonstrates a clear synergy between science and practical farming, creating a production process that is both efficient and environmentally friendly. The use of advanced machinery also reflects the forward-thinking approach of American farmers in building a modern, competitive agricultural industry. They not only prioritize higher yields, but also focus on sustainable practices and innovation. These machines not only boost production capacity, but also allow farmers to dedicate more time to strategic tasks, such as developing better crop varieties or refining farming techniques. Now let's feel the most realistic harvesting processing with vivid sound. After harvest, carrots are transported to factory for further processing. At the factory entrance, carrots are unloaded from trucks onto a conveyor system, where they are gently and continuously moved along. The conveyor transports the carrots into large storage bins designed to protect the produce from damage. These filled bins are then quickly and efficiently transported into the factory by forklifts. This process not only optimizes time, but also preserves the freshness and quality of the carrots before they move on to the next stages of processing. Next, the carrots are transferred to a modern washing line. The carrot washing process in the factory begins with the carrots being transferred from the main conveyor to a specialized washing system. First, they pass through a large water tank equipped with high-pressure water jets that remove dirt and soil from the surface. Next, the carrots move through rotating drums or conveyors with soft brushes that scrub away any stubborn dirt without damaging their natural skin. The water used in this process is continuously filtered and recycled to to ensure efficiency and environmental friendliness. Following this, the carrots are rinsed once more with clean water to ensure they are completely sanitized. Finally, they are gently dried on a conveyor before being moved to the next stages of processing. This meticulous process ensures that each carrot meets the highest hygiene standards before reaching consumers. After being thoroughly washed, the carrots are moved to a size sorting conveyor equipped with special rolling bars. These bars have gaps of varying sizes, allowing smaller carrots to fall through while larger ones continue along the conveyor. This process ensures precise sorting of carrots by size before they proceed to the next stages of processing. Next, the carrots are sent to an automated sorting system equipped with advanced sensors. These sensors scan each carrot to assess its size, color, and shape, then automatically sort them into appropriate categories. This process is not only fast but also highly accurate, ensuring optimal product quality before processing or packaging. After being sorted, the carrots are transferred to an automated packaging line. Here, they are precisely weighed to ensure the correct weight for each type of packaging. The carrots are then placed into bags or boxes, with the automated system sealing or closing them and applying product labels. Finally, the completed carrot packages are stacked onto pallets, ready for transportation to stores or distributors. Besides, they are also made into carrot juice. Let's witness this process. Today, we're taking you on an amazing journey into the world of this tiny, yet nutrient-packed crop. From high-tech harvesting across vast American fields to state-of-the-art factories where fresh peas are carefully processed and packaged to reach your table, we'll explore it all. We'll dive into how farmers grow, nurture, and harvest peas, as well as the advanced technologies used to ensure these little green gems are always at their freshest and most flavorful. So let's jump right in and uncover the magic behind peas. Let's get started now. Peas are one of the standout crops in American agriculture, playing a crucial role in providing fresh, frozen, or canned peas for the food industry. They're commonly grown in states like Washington, Wisconsin, Oregon, and Minnesota, where the cool climate and well-drained soil create the perfect conditions for their growth. Not only are peas a staple crop in the US, but they also thrive globally, especially in Europe, where they hold a prominent place in agriculture and cuisine. Farmers worldwide have mastered the art of growing peas, combining traditional farming techniques with modern technologies to achieve high-quality yields that meet global demand. Every story about green peas begins in the fields. In early spring, when soil temperatures reach around 40–45 degrees and the threat of frost has passed, farmers get to work planting peas. The first step is soil preparation. Advanced machinery like disc harrows and rotary tillers are used to loosen the soil, improve aeration, and remove weeds. This creates the perfect environment for pea seeds to germinate and grow. Next, farmers apply organic or mineral fertilizers evenly across the fields using spreaders, ensuring the soil is nutrient-rich to support healthy crop growth. Once the soil is ready, the next step is planting. Pea seeds are often treated with nitrogen-fixing inoculants before sowing to enhance their natural nitrogen-fixing ability and protect them from soil-borne diseases. Using modern seed drills, farmers carefully place the seeds at a depth of 1 to 2 inches below the surface, spaced 1 to 2 inches apart in rows that are 18 to 24 inches apart. Thanks to advanced technology, the planting process is not only quick and efficient, but also highly precise. With these tools, farmers can plant dozens of acres in just one day, setting the stage for a bountiful pea harvest. Once the pea seeds sprout, American farmers use automated irrigation systems to deliver consistent water supply, ensuring the ideal moisture levels for the plants to thrive. Fertilizers are applied periodically using modern spreaders, allowing the plants to absorb nutrients effectively without waste. On vast fields of green peas, sophisticated sprayers glide smoothly between rows, coating the leaves with a fine mist of protective solutions to safeguard against pests and diseases. Thanks to the integration of modern technology, caring for peas is efficient and ensures the plants grow strong and produce optimal yields. Green peas grown in the U.S. are typically ready for harvest about 50 to 70 days after planting. The ideal time to harvest is when the pods have reached full size, are plump, and yet remain tender. Across the vast temperate fields of America, pea harvesting has evolved far beyond manual labor, thanks to advanced machinery. Two primary types of harvesters are commonly used: conventional pod harvesters and integrated seed harvesters. First, we come to the whole pea harvester. Conventional pod harvesters are basic machines designed to collect entire pods from the plants. As they operate, a front-mounted reel system gently guides the pea plants into the machine. Flexible stripping fingers or rotating brushes detach the pods from the vines without damaging them. The collected pods are then transported via conveyor belts to large storage bins at the rear of the machine. Meanwhile, the plant stems and leaves are left behind in the fields to decompose naturally, acting as a green manure that enriches the soil. This approach not only saves the farmers from post-harvest cleanup, but also enhances soil fertility for future crops. These machines are particularly popular on large farms due to their lower cost and quick harvesting efficiency. However, since the pods remain intact, additional processing is required at the factory to shell the peas. Next, we will learn about the harvesting process, where the shell has been separated from the seed. On large-scale farms, or in regions specializing in frozen pea production, integrated seed harvesters are the ideal choice. These machines not only harvest the pods, but also separate the peas from their shells right in the field, streamlining the process and saving valuable time in post-harvest handling. These harvesters operate much like conventional ones, with a front reel system that gathers the pea plants. However, instead of keeping the pods intact, these machines are equipped with an internal shelling chamber. The pods are fed into the chamber, where high-speed rotating drums gently strip the peas from their shells. The empty shells are then crushed and returned to the field through a rear discharge system. The fresh, tender peas are transported via conveyor belts to large storage bins at the back of the harvester. This system ensures that the peas remain intact and maintain the highest quality standards. Picture an early morning on a sprawling pea field where massive harvesters line up in formation, slowly moving through rows of lush green pea plants. The hum of engines blends with the rustling breeze, and the faint, fresh aroma of peas fills the air, creating a harmonious and vibrant scene of agricultural labor. These modern, integrated harvesters not only help farmers complete their work faster, but also ensure uniform quality for every pea harvested. Once collected, the fresh peas are promptly loaded into large storage bins and transported to processing facilities. Harvesting peas isn't just an agricultural task. It's a seamless blend of human effort and cutting-edge technology. From basic pod harvesters to advanced integrated machines, each tool brings unique value to meet the diverse needs of the agricultural industry. With every tender, green pea we enjoy, we can taste the dedication of farmers, the advancements of technology, and the love for these bountiful fields. It's this perfect harmony that makes peas a wonderful gift, crafted together by nature and humanity. In addition to machine harvesting, some green peas are harvested by hand. Farmers walk slowly between rows of pea plants, carefully lifting each leafy branch to find plump, ready-to-pick pods. With precision and care, they gently pluck the pods from their stems, preserving their freshness while leaving the lush greenery intact for future harvests. Once harvested, the peas are swiftly transported to the factory to begin processing. Upon arrival, workers wash their hands and don protective gear to ensure food safety and hygiene. The pods are then trimmed, with any substandard ones removed in preparation for cleaning. Next, the peas are fed into an automated washing system where all soil and impurities are thoroughly removed. Finally, the peas are carefully packaged using advanced assembly lines, ensuring they are ready for storage and distribution. Next, we come to the process of processing frozen green beans. When the peas arrive at the factory, they are unloaded into large intake hoppers. The shelled peas are then transported via conveyor belts through a screening system to remove impurities such as soil, stones, and leftover stems or leaves. Next, advanced optical sorting machines inspect each pea for size, color, and quality. Only the plumpest, brightest green peas make the cut, while those that don't meet the standards are discarded. After sorting, the peas move to the washing area. Large water tanks and high-pressure sprayers combined with air bubbles ensure that every pea is thoroughly cleaned, removing dirt and bacteria. Some factories use chilled water during this step to maintain the pea's freshness before proceeding to the next stage. Blanching is a critical step in preserving the vibrant green color and natural sweetness of peas. The peas are submerged in hot water at temperatures between 185 degrees and 203 degrees Fahrenheit for a few minutes. This process kills bacteria and halts enzyme activity that could cause spoilage. Immediately after blanching, the peas are rapidly cooled in an ice water bath to lock in their crisp texture and freshness. The selected peas are subjected to quick freezing at -40 degrees. This flash freezing process ensures that each pea is individually frozen, preserving its freshness, color, and nutritional value. It also allows the peas to maintain their quality over extended periods of storage. After freezing, the peas move to the packaging area. There are workers standing here to remove substandard seeds. Automated packing machines accurately weigh and portion the peas into bags, which are then vacuum sealed or filled with preservation gases to extend shelf life. In addition, frozen green beans are also packed into cans using modern production lines. And there you have it. Together, we've explored the entire journey of green peas. from lush fields to the harvesting and processing of millions of fresh, vibrant pods. If you have any questions or thoughts, feel free to leave a comment below. And don't forget to like this video and subscribe to the channel to uncover even more amazing stories from the world of agriculture. See you in the next video.